Dear students, in the last class we solved problems on implicit functions. We found the derivatives of implicit functions. Today, let us see some more problems on implicit functions. Okay. Take the first question. If x by a whole power n plus y by b whole power n is equal to 1. Is equal to 2. Then find dy by dx. Find dy by dx at AB. So we are asked to find the derivative dy by dx at this point, at a comma b, at AB. That means at x equal to a and y is equal to b. Okay. So now I'll take this x by a whole power n plus y by b whole power n is equal to 2. This is the function, this is the expression they have given. Now let us differentiate this with respect to x. Differentiate with respect to x. When I differentiate this with respect to x, derivative of x by a whole power n, x on the form x power n, derivative of x power n is n into x power n minus 1. So the derivative of this is n into x by a whole power n minus 1 into, now the derivative of x by a, derivative of x by a is 1 by a plus, here the derivative of y by b whole power n is n into y by b whole power n minus 1 into the derivative of y by b. There 1 by b is constant, will remain as this. Now I write the derivative of y. Derivative of y is dy by dx. On RHS we have 2, so its derivative will be equal to c. Oh, so now what do we want? We want dy by dx at AB. So put x equal to a and y is equal to b. At AB, let us see what happens. This will be n into, here I am putting x as a by a is 1 power n minus 1, n into 1 by a, so n by a plus y is equal to b by b is 1 power n minus 1, that is 1 plus n by b into dy by dx is equal to n by a plus n by b into dy by dx. Take this n by a to RHS. So you will have n by b into dy by dx is equal to minus n by b. Right? I am taking n by a to RHS. Now take this n by b here, n gets cancelled, b will go to. Okay? So n by b will go to the denominator, so b will come out. Which means dy by dx at which point? At a comma b is equal to minus b by a. So you are asked to find dy by dx at this point, at a. So what did I do? After differentiating, I have substituted this. I have put x equal to a and equal to b. This is what we get. Dy by dx at ab is equal to minus b by a. Okay. Let us look at the next question now. If e power x plus e power y, if e power x plus e power y is equal to e power x plus e power y is equal to e power x plus y, then prove that dy by dx is equal to minus e power y minus x. Dy by dx is equal to minus e power y minus x. Okay. So we have e power x plus e power y is equal to e power x plus y. So this is not a general rule. Only in this problem they have given e power x plus e power y is equal to e power x plus y. Then we have to show that dy by dx is equal to minus e power y minus x. Let us take out. Then we take this e power x plus e power y is equal to e power x plus y. Now we will differentiate this with respect to x. We are differentiating it with respect to x. Derivative of e power x is e power x itself plus the derivative of e power y is e power y into dy by dx is equal to derivative of e power x plus y. Derivative of e power x plus y is e power x plus y into the derivative of x plus y. Derivative of x is 1 plus the derivative of y, which is dy by dx. Okay? Then e power x plus e power y into dy by dx is equal to, I will replace e power x plus y with e power x plus e power y. Okay. Now, don't think, sir, e power x plus y we must write it as e power x into e power y. That is right. That is a general formula. In general, e power x plus y can be written as e power x into e power y. Only in this particular problem, they have already given that e power x plus e power y is equal to e power x plus y. So I am replacing e power x plus y with the e power x plus e power y into 1 plus dy by dx. Okay. So now let us simplify this. E power x plus e power y into dy by dx. On RHS, I will expand it, I will just multiply. We get e power x plus e power x into dy by dx plus e power y plus e power y into dy by dx. Okay. So I am just multiplying e power x into 1 plus e power x into dy by dx plus e power y into 1 plus e power y into dy by dx. Now just observe, here we have e power x, here also e power x, these two e power x gets cancelled. And similarly, e power y into dy by dx, here also we have e power y into dy by dx, those two gets cancelled. Okay. So now we are left with 0 is equal to e power x into dy by dx plus e power y. Okay. Which means e power x into dy by dx is equal to minus e power y. I am bringing e power y to LHS. So minus e power y. So dy by dx is equal to minus e power y divided by e power x. Minus e power y divided by e power x. That can be written as minus e power y minus x. E power y by e power x is equal to e power y minus x. That's what we want. dy by dx is equal to minus e power y minus x. Okay. Let us look at the next question. If x into root 1 plus y, if x into root 1 plus y plus y into root 1 plus x is equal to, see, x into root 1 plus y plus y into root 1 plus x equal to 0. Y not equal to x, y is not equal to x. Then prove that dy by dx is equal to minus 1 by 1 plus x whole square. So that dy by dx is equal to minus 1 by 1 plus x whole square. Okay. We have x into root 1 plus y plus y into root 1 plus x is equal to 0. Let us not directly differentiate this because we don't want the answer in terms of root 1 plus y. If I directly differentiate it, we are going to get x into 1 by 2 root 1 plus y into dy by dx plus, I am using product rule. But that dy by dx will definitely contain root of 1 plus y and root of 1 plus x. But if you look at what we want, then we want to show that dy by dx is equal to minus 1 by 1 plus x whole square. Okay. So before I differentiate it, let us simplify this. I take this term to RHS. We get x into root of 1 plus y is equal to minus y into root of 1 plus x. Now let us square this. X square into 1 plus y is equal to y square into 1 plus x. Minus y whole square will become y square. Simplify. X square plus x square y is equal to y square plus xy square. Bring all of them to LHS. Get x square minus y square plus x square y minus xy square equal to 0. I am bringing these two terms to LHS. Now here the first two terms we have x square minus y square. X square minus y square, I can write that as x minus y into x plus y plus. Here x square y minus xy square we have, in that I will take xy as common. So if I take x into y as common, then what will remain? X minus y is equal to 0. Now between these two terms, there is a common factor which is x minus y. I will take that out. So if I take x minus y out, what will remain then? X plus y plus xy is equal to 0. Okay. Now this product is 0. Product of these two factors is 0. When the product is 0, means either this is 0 or this is 0. Okay. So at least one of these two must be equal to 0. But if this is equal to 0, if x minus y is equal to 0, then we get x equal to y. But what they have given in the question? Y not equal to x they have given. Of course, which means x not equal to y. So x not equal to y they have given. So x minus y cannot be equal to 0. Therefore, this factor must be equal to 0. So that implies x plus y plus xy is equal to 0. X plus y plus xy equal to 0. Okay, now differentiating this is much more easier when compared to differentiating this. Okay, here also I shall not directly differentiate it, because see what we want to prove. We want to prove that dy by dx is equal to minus 1 by 1 plus x whole square. So here dy by dx, this is in terms of x only. So here, in order to get such an answer, what we want is, we want an explicit function of x. We want y as a function of x only, and then if you differentiate, that derivative will also be in terms of x only. Whereas as it is, if I differentiate, that derivative will contain x as well as y, which we don't want. Okay. So before I differentiate, I will write down y as an explicit function of x. So I will take y as a common factor between these two. Y into 1 plus x is equal to minus x. So y is equal to minus x divided by 1 plus x. Okay. So y as a function of x only. Now differentiate it. dy by dx is equal to, I am using quotient rule in the denominator 1 plus x whole square, in the numerator 1 plus x into derivative of minus x, which is minus 1, minus x into derivative of 1 plus x, which is 1. So this is equal to minus 1 minus x plus x divided by 1 plus x whole square. X gets cancelled. So we have dy by dx is equal to minus 1 by 1 plus x whole square. Next problem. If y log x is equal to y minus x, y log x is equal to y minus x, then prove that dy by dx is equal to 2 minus log x divided by 1 minus log x whole square, divided by 1 minus log x whole square. Okay. So they have given y log x is equal to y minus x. I will bring y to this side. Y log x minus y is equal to minus x. I take y as common. Y into log x minus 1 is equal to minus x. Or y is equal to x divided by 1 minus log x. Okay, I have taken minus as a common factor here. So it has become minus of 1 minus log x, and then this minus, that minus, and it's cancelled. We will have y is equal to x by 1 minus log x. Why did I do this? Instead of directly differentiating this, that question may arise in your mind. The reason why did I do it is by looking at what we want to prove. We want to show that dy by dx is equal to 2 minus log x divided by 1 minus log x whole square. Look at this, dy by dx is a function of x only. We will get dy by dx as a function of x only, provided y is a function of x only. So I want to know what is y. So as it is, if I differentiate it, here in the dy by dx what we get, that will be in terms of x as well as y. Now I want dy by dx in terms of x only. So first we have to write y in terms of x only. This is what we have got. Now let us differentiate. Y dash is equal to, let us use quotient rule here. Denominator will be 1 minus log x whole square. In the numerator, 1 minus log x into derivative of x, which is 1 minus x into derivative of 1 minus log x. What is the derivative of 1 minus log x? Derivative of 1 is 0. Derivative of minus log x is minus x. Minus 1 minus, sorry. So this is equal to 1 minus log x. Here x gets cancelled. Minus of minus will be plus 1. Divided by 1 minus log x whole square. So y dash is equal to 1 minus log x plus 1. That will give you 2 minus log x divided by 1 minus log x whole square. Okay? Say I am using quotient rule. 1 minus log x whole square. Numerator 1 minus log x into derivative of x, which is 1 minus x into the derivative of 1 minus log x, which is minus 1 minus. So after simplification, we get y dash as 2 minus log x divided by 1 minus log x whole square. Then if sin y is equal to x into sin a plus y, then prove that dy by dx is equal to sin square a plus y divided by sin a. Prove that dy by dx is equal to sin square a plus y divided by sin a. Well, see, in the previous problem I told you that we wanted the derivative dy by dx in terms of x only. So what did we do? We wrote y as an explicit function of x, then we differentiated it and got the answer dy by dx in terms of x only. But in this problem, we want dy by dx as sin square a plus y divided by sin a. This is in terms of y only. Okay. Now you might say, sir, there is a also. Yes, you are right. But that a is a constant. Okay, don't worry about that. So y is the only variable here. We don't have x here. Dy by dx, we want the answer in terms of y only. We want dy by dx as a function of y only. Okay. That means y must also be a function of y only. Or in other words, we can write x as a function of y. See, from this equation, I will write x is equal to sin y divided by sin a plus 1. Okay. I am bringing sin a plus 1. X is equal to sin y divided by sin a plus 1. Now we have x as a function of y. X is equal to f of y. Now we will differentiate this with respect to y. When I differentiate x with respect to y, we get dx by dy. Okay. Since we are differentiating it with respect to y, here answer will be in terms of y. We will get dx by dy in terms of y, and in the last step we will take the reciprocal, so that we will get dy by dx, which will also be in terms of y. Okay. So now in this particular problem, we shall differentiate this with respect to y. Differentiating with respect to y. When we differentiate it with respect to y, we get dx by dy is equal to dx by dy is equal to, in the denominator, sin a plus y is there. So I am using quotient rule. So sin square a plus 1. Here what do we get? Sin a plus y into the derivative of sin y. See, earlier I told you derivative of sin y is cos y into dy by dx. That is when you are differentiating it with respect to x. Now you are differentiating with respect to y. So derivative of sin y will be cos y. That's all. If you want to write something else, then you should write d by dy of y. D by dy of y is 1 itself, right? So, say derivative of sin x with respect to x is cos x. So derivative of sin y with respect to x will be cos y into dy by dx. Now I am talking about derivative of sin y with respect to y. So it will be simply cos y, that's all. Derivative of sin y is cos y. Or you can say cos y into derivative of y with respect to y, which is 1. Cos y into 1 will give you cos y. Okay? So this step is not necessary actually. Minus sin y into the derivative of sin a plus y. Derivative of sin a plus y is cos a plus y. Cos a plus y into the derivative of a plus y, which is 1. Derivative of a is 0, derivative of y is 1, as we are differentiating with respect to y. So then dx by dy is equal to, in the denominator, sin square a plus y. In the numerator, look at the numerator. This looks like sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is equal to sin a minus b. Sin a minus b means in place of a we have a plus y minus b that is y. So sin a plus y minus y. Okay. So then y gets cancelled. So we will have dx by dy is equal to, numerator will be sin a, denominator is sin square a plus 1. This is dx by dy. We want dy by dx, so we shall take the reciprocal of this. Taking the reciprocal of this, we get dy by dx is equal to sin square a plus y divided by sin a. Sin square a plus y divided by sin a. Next question. If x power m into y power n is equal to x plus y to the power m plus 10, then prove that dy by dx is equal to y by x. Okay? If x power m into y power n is equal to x plus y whole power m plus n, then prove that dy by dx is equal to y by x. Okay. So we have this x power m into y power n is equal to x plus y whole power m plus n. Let us differentiate this with respect to x. Differentiating with respect to x, I am using product rule here. X power m into derivative of y power n, that is n into y power n minus 1 into dy by dx plus y power n into derivative of x power m, which is m into x power m minus 1. That's equal to, on RHS, the derivative of x plus y whole power m plus n, which is m plus n into x plus y whole power m plus n minus 1 into 1 plus dy by dx. Okay, did you understand this step? Here x plus y whole power m plus n, so its derivative will be m plus n into x plus y whole power m plus n minus 1 into 1 plus dy by dx. Okay, so n into x power m into y power n minus 1 into y dash or dy by dx, plus m into x power m minus 1 into y power n is equal to, I will write this x plus y whole power m plus n minus 1 as x plus y whole power m plus n divided by x plus y. Okay, so m plus n into x plus y whole power m plus n divided by x plus y into 1 plus dy by dx. Okay, so now I will bring this x plus y into LHS. Okay. I'm just cross multiplying. So when I cross multiply x plus y into n into x power m into y power n minus 1 into dy by dx plus m into x power m minus 1 into y power n is equal to, on RHS we have m plus n into x plus y whole power m plus n is there, no? I will write that as x power m into y power n. Look here, they have given x plus y whole power m plus n is equal to x power m into y power n, that I will replace into 1 plus dy by dx. Okay. So now multiply. When I multiply, I am going to get n into x power m plus 1 into y power n minus 1 into dy by dx. That is the first term. Plus second term, first I am multiplying by x. So m into x power m into y power n plus, now I am multiplying by y. So n into x power m into y power n into dy by dx plus m into x power m minus 1 into y power n plus 1, okay, is equal. Now here also I will multiply m into x power m y power n plus m into x power m y power n into dy by dx plus n into x power m into y power n plus n into x power m into y power n into dy by dx. Okay, see whether we can cancel any of these terms. M into x power m y power n gets cancelled. Similarly, n into x power m y power n dy by dx gets cancelled. Now take the terms containing dy by dx on one side and the remaining terms on the other side. So I am writing n into x power m plus 1 into y power n minus 1 dy by dx minus, I am bringing it to LHS, m into x power m y power n dy by dx. That is equal to, on RHS this term is remaining as it is, n into x power m y power n minus, and now this term I am taking it to RHS. That will be m into x power m minus 1 into y power n plus 1. I don't have enough space, so I will run this. Okay. So here between these two, what are the common factors? Common factors are x power m into y power n minus 1 into dy by dx. I will take x power m into y power n minus 1 into dy by dx as a common factor. So from this x power m I have taken, so one x will remain, n will remain, nx will remain, minus, see we have taken x power m as common, so and y power n minus 1 as common, so one y will remain, nx minus my will remain. That's equal to, here on RHS I will take x power m minus 1 and y power n as common, x power m minus 1 y power n as common, then here nx will remain. On RHS, on here in the next term, as we have taken x power m minus 1 as common and y power n as common, my will remain, my. So that nx minus my gets cancelled. We have x power m y power n minus 1 into dy by dx is equal to x power m minus 1 into y power n. Take this to RHS. Dy by dx is equal to x power m minus 1 into y power n divided by x power m into y power n minus 1. So we get dy by dx is equal to y power n divided by y power n minus 1. This will give you y power n minus of n minus 1, which is y power 1. Denominator x will remain. X power m minus 1 gets cancelled. X will remain. So we will get dy by dx is equal to y by x. Okay? Then next question. If x is equal to e power y plus e power y plus e power y plus e power y, so on up till e power y plus e power y plus e power y etc. up till today, then find dy by dx. Find dy by dx. That's the question. Okay. X is equal to e power y plus e power y plus e power y plus e power y. Say, understand, it's not like this. X is equal to, it is not like this. Okay. This plus is not e power y plus e power y plus e power y. What they have given here is e power y plus e power y plus e power y plus e power y. It will go in this way up to infinity. Then what is dy by dx? That is what we want. Okay. So now x is equal to e power y plus e power y plus e power y etc. There are infinitely many e power y's. Now among those infinitely many e power y, if I remove one of those, say let us remove, I remove this e power y, then what do you have? E power y plus e power y plus e power y plus e power y up to infinity. Don't say infinity minus 1. Still it is infinity. Okay? So apart from this, still there are infinitely many e power y's. That can be written as x. So we will get x is equal to e power y plus x. Okay? Now we differentiate it. Differentiating with respect to x, as we want dy by dx. Differentiating with respect to x, derivative of x is 1. Derivative of e power y plus x is e power y plus x into the derivative of y plus x. Derivative of y plus x is dy by dx plus 1. Okay? So that means we will have 1 is equal to e power y plus x into dy by dx. E power y plus x into dy by dx plus e power y plus x. Okay? So e power y plus x into dy by dx is equal to 1 minus e power y plus x. Or I can write dy by dx is equal to 1 minus e power y plus x divided by e power y plus x. Okay? So that's all. We need not simplify this one. This much is enough because the question is only to find dy by dx. They have not asked us to prove anything. Okay? So with this I will stop today's class. So with this we have come to the end of derivatives of implicit functions. In our next class we will discuss logarithmic differentiation. Okay? Differentiation by using logarithms. That we will discuss in the next class. Thank you.